All right, so I had you do 6 of these problems, and we will eventually do the rest of them. We might not get to the inference ones till like March, so don't lose this packet, and you'll get other packets. This is from an actual test about 13 years ago. All right, going in order, if you want to write down the answers for 1, 7, 12, 15, 24, and 29, it was cat, dog, egg, dog, dog, egg. So cat, dog, egg, dog, dog, egg. And if you missed one of them, that's what the bottom of this sheet is all about. You making some notes to yourself, especially if it's one that like is really tricky. So how do I figure out which ones we need to go over? Well, that's a good question. You guys filled out this form last week, and here is the distribution right here. This tells me that out of the 47 people that responded, and there should really be 49 people that responded, so there's still 2 people that haven't entered their answers yet. 2 people got only 1 of the 6 right. 4 people got 2 of the 6 right. 12 people got at least 50%. 12 people got 4 of the 6. 10 people got 5, and 7 people got them all right. So we have 40 of us that have some question somewhere. And then it tells me the questions that were under 50%, which was question 12. Sadly, only 16 of us out of 47 got that. Then it gives me everybody's individual scores, which we will right past. And then it gives me a basically a bar chart for each question. Question 1, 35 out of 47 got it right, so I'm feeling pretty good about that. Question 7, pretty good about that, 36. Here's question 12. And I totally understand why some people put D, and I'm going to explain why that is wrong. Number 15, not terrible, but I think if we did 15 today, that would go up to, instead of 27 right, I bet would go up to at least 37, maybe 45 of us would get it. 24, 32 of us got it right, and then 29, 85%, 40 out of 47 of us got it. So that makes me feel very good. So let's go over 12, 15, and 14. And if you missed one of the other ones, then I will tell you what to do momentarily. Okay, here is 12. 12 is asking you to find the new median if you were to combine these 2 data sets. Well, if they put the word mean in here instead, to find the mean, this is a weighted average problem. It's as if we had 42.6 added up 21 times plus 49.2 added up 26 times. And if you added all those numbers up and divided by 47, that would give you the new mean. So this answer C is the new mean. So I know a lot of you, some of you chose that, and some of you thought, oh, well, if that's the way you find the mean, why not just do the same thing for the median? So that's why many of you chose D. But here's the problem. How do you find the median of a data set? It's positional, right? To find the median of a data set, you need to know what the middle data points look like. Like for this being 21 pieces of data, I would like to know what data piece 9, 10, 11, 12, 13 looks like, and then I can tell you what the median is. But they didn't give us any data, so there's no magic formula for the median. This formula does not apply to the median. So the answer is E, because median, and I don't care if you write this here or if you write this on that sheet I gave you. This is for you to take notes on, like, man, these types of multiple choice questions are constantly getting me. So that's what I hope you'll learn about yourself before May 13th. Medians are positional. You need actual data points to find them. That's why we can't determine it from the information that they gave us because they didn't give us enough information. Does that make sense to everybody? All right. Take a look at 15. It's the next one we were having trouble with. All right. Now, because of all this matching and stuff that we've done, can you look at that and tell me which one has the biggest standard deviation? The one that has a bigger standard deviation looks like they have pushed stuff away from the middle, right? And which one has the biggest push away from the middle? D. So I'm relatively confident that our score on that would go way up if we were to do that question today. So standard deviation is greatest when data is, and I'm going to call it quote, pushed or distanced away from the center. That's where our standard is. The standard is the mean. The standard deviation is how much are we standardly away from the main standard? Like how much is our average distance from the average is what it's asking. That it's wrong to define a term using that term. So that's why we say it's the typical amount a data point differs from its mean. All right, and then the last one. Does anybody have any questions on this one? Well, let me ask a question. Which one has the smallest standard deviation here? C. It's most packed to the middle. E is, if this is my middle, then you got some data points that far, and some data points this far, and some data points that far, and you also have that on the other side. Those are all what I call like the residuals or the deviations from the center. And then between A and B, they probably have very similar standard deviations. What has a bigger standard deviation, Mrs. Garrett, B or E? I'm going to think that the answer is E, but I'm not sure. It kind of depends upon where that's a really hard one to tell. I don't think, I could be wrong, somebody correct me. I don't think you can really tell unless you put the data in and calculate it out for those two. Because it really kind of depends upon what this data is and how far those data points are. We don't have any scales. Okay, process of elimination. This is why when we take a practice multiple choice for real, which we will do, but not for a while, I will give it to you partial credit multiple choice because I think this is an easy one to get a 3 out of 4 on. They tell us that this data point right here is a 93, and they even show us the calculation for it. So first thing I would do is go around and say, does that little point look like it's right after the 90 hash mark? And yep, it does. So there's nothing I can get rid of yet. But where's the next data points after that? Back from that, they have to be between what? 60 and, so does this tail stop between 60 and 70? Nope, it's too far out. That tail stops after 80, that's too far out. Does this tail stop between 60 and 70? Yep. How about this tail? Yep. How about this tail? No. So right now I know my answer is either C or D. And you can do that fairly quickly. But now you're going to have some calculations. Who can tell me what they did next? Thank you. I was going to say there's so many hands up, I don't know who to call on. Thank you, Marcus.
I didn't do any math, but I just had to guesstimate the median.
Okay. And how'd you guesstimate the median?
Kind of where the most like frequency was.
Okay. So you knew it was somewhere in the 20s to 30s?
Yeah.
All right. And if you take his guesstimation and put some math behind it, it tells us we have 26, right? 26 divided by 2 means the median is between position 13 and position 14. What bar is position 13 and 14 in?
20.
Here are 6, 10, 16. So right here, the 20s to 30s is the bar that's going to hold my median. So now let's look. Is this bar right here between the 20s and 30s? It's before the 20s, right? How about this bar? Is that bar between the 20s and 30s? Yep, that bar is between the 20s and 30s. So the answer is D. Now I would like to know, because I don't want to take up time from our team activity, but I would like to know, of 1, 7, and 29, is there anybody else that would really like an explanation of one of those? Because we will have time later this week for me to explain that. Anybody? 1, 7, or 29? 1, 7, 29. 1? I will tell you that I dislike, I can do this one really quick. I dislike problems like 7 and 29. Those take me the longest time to do. I usually try to scratch off a couple answers and then come back and finish that when I have more time, because those comparative box plots or stem and leaf, it's like, I have to really pay attention on this one. All right. So we have 200 young children, right? Henry?
Yes.
Okay. So they tell me what the mean, the median, the standard deviation, the first quartile, and the second quartile are. All right? So if I were to draw a box plot, which I am not going to draw it very nicely, but with 200 children, how many children are in this first tail?
50.
And how many are in here?
50.
And in here?
50.
And in here. So I don't know where the, whatever it is, but I know that this is 43, and this is 45, and this is 48, and I don't know the maximum or the minimum.
Oh, all right, I can check.
So now what's the answer?
C.
Mm-hmm. Because less than 48 is only 50 of them. Less than 43 is only 50 of them. If they would have said less than 45, then you would have had 2 answers.
Yeah, I just wrote it wrong.
Yeah, and if they would have put more than 45 inches, there would have been 2 answers also. So yeah, that one was an easy one. But this one, number 7, and number 29, those are my least favorite types of multiple choice problems. But I'd be happy to go over them someday for somebody. All right. We are going to, I think your packet's technically over now, isn't it? That first packet, I'll give you a new packet tomorrow. And our packet ended on page 16. So you can really call this page 17 of your packet. I think I have it added to, call it 19, but this should really be 17. So Lily, this is the field day one. Again, you don't have to print this out if you don't want to, but you do need a piece of paper to have this for yourself to do work on. Okay, so something we haven't done with descriptive statistics is calculate outliers again. Oh, sorry. So we're going to quickly review how to calculate outliers, and then I'm going to put you, with a team. And with your team, we're going to do a challenge. that is worth 20 points, which will go into the team challenge place, and Lily will have a team as well. And I'll explain that after we practice this a tad. Okay, so here we are. Does anybody remember this problem? A few of you should. Does anybody know where you might have done this in the past? If you did not have honors statistics last semester, and if you did not have honors statistics in the spring, you would have seen this problem. It was on your final exam.
Oh, yeah.
And you had to write a funny story about who was behind and why. Like Mr. Link got behind because he saw another band practicing and he had to go over and show them how to march correctly, and or Mr. Turk, you would have thought he would have been the fastest, but he is actually the slowest because in the middle of the obstacle course he saw a nice rock for climbing on and he got distracted and went climbing up and down the rock, and then, oh yeah, I have to finish the obstacle course race. So it's kind of fun. Cultus gets picked on a lot for being the person who finished in 30 minutes. But I'll tell you, in his day, like when he was a teenager, he was pretty quick in the 100-meter dash. He actually ran sprints in the track. Just saying. Okay. So here we go. The first thing I want you to do is find your fluorescent green page, and we're going to add a formula to this page because pretty much the AP people that are in charge of things have said that while the formula is not on your green paper, if you ever have to do an outlier, they will put that formula on the test. And we saw that with question number 24 just now. It was on their test, and I can show you right here. I circled it. So this is the outlier formula right here, these. And I would like you to put those up in the corner of your AP green sheet. So right underneath that big standard deviation thing, I think you can put a little box in and say outlier test, and then put these formulas. You can just put B or BOT for bottom or TOP for top, and put those on your formula sheet. It's actually kind of funny why it's not on your sheet to begin with. That's a story for another day. Okay, ready to do this? Let's see if the students have any outliers. So I'm going to put students, and I'm going to do the top, and then I'm going to do the bottom. So the top outliers, the formula, you don't have to write this down, you already have it, is Q3 plus 1.5 times the box, which is Q3 minus Q1. All right, and that's going to be, for the students, 13.75 plus 1.5 times 13.75 minus 6.75. And what's 13.75 minus 6.75? That is 7. And 7 plus half of itself. 7 plus half of 7 is $3.50. So if I have $7 and $3.50, I got $10.50. $10.50 is what I call the litmus test, or the stick, to see if you're an outlier. So you don't have to draw this, but this is basically what I'm doing. I have said that this is the 6.75 and this is the 13.75, and the box is of length 7. To see if there's an outlier, I'm going to take 7 plus 50% more. So 7 plus this plus half of it again would be about like that. So I'm going to take this stick, this blue stick, and put it onto the top of the box. If there's anybody out here, it's an outlier. But I'm also going to take that stick and I'm going to stick it on the bottom of the box. And if there's anybody down here, it's an outlier. That's basically what it's doing, geometrically speaking. All right, so let's see. I have 13. Nope, I wanted to write in green. Wanted to write in green. Go away. You. Okay. So 13.75 plus 1050 is equal to 2375 plus 50 more cents, 2425. That's my cutoff. Are there any students that finished longer than 24-25 minutes? The maximum for the students was 1650, so there are no top outliers. There's none. Let's do the bottom. Once you got the top done, the bottom's a little easier to do because it's Q1 minus 1.5 times Q3 minus Q1, which we already know is 1050. So that's going to be 6.75 minus 1050, and that's going to be a negative number, and the minimum is a positive 375, so I really don't care what negative number it is, but it's actually negative, what, 3 point something, 25 or 75 or 50, I don't remember. Oh, it can't be 50. Is it 3.25? 3.75, so that's a coincidence. This is positive 3.75, that's negative 3.75. There are no bottom outliers for the students. All right, so why don't you take a moment to do the faculty. The top and the bottom of the faculty. And you do not have to write down this formula like I am. It's just I'm the teacher, and so my teacherness tells me I should be doing this. And I shall be the claw. All right, Mr. Nelson. What is the top outlier cutoff? 1575 plus. What did we get again for the 1.5 IQR? Did you get 1050 again? For this part right here.
For 1.5.
Times that difference.
Yeah, 10.5.
Okay, so 1575 and 10.5 is 26 point. And if we use that cutoff and we go up here and look at the maximum for the adults, we say, uh-oh, there is an outlier. Because 30 is definitely above the 26.25. So we have one, at least one at 30. Now, why do I know that I only have one and not two or more? Who can tell me why I know there's only one? Have to do something. We're looking at the prompt. It says what? All the teachers completed the course in 24 minutes or less, except for this person you're going to make fun of. So 24 is under the 26, 25, so I know I'm good. I just have one on the top. And now if we do 8.75 minus 10.5, I get a negative number again. And that negative number is, Michael?
Negative 1.75.
And do we have any negative, is it even possible to complete an obstacle course in negative time? Only if you're the Flash and you can go backwards or something. Even the Flash probably can't do it that quickly. If you could turn back time. Who sings that song? Come on. If I could turn back time.
Chorus, aren't you?
Share.
Yeah, sure.
Sonny and Cher?
Right,
Share.
right.
Yeah. So only Cher can do that. All right. So we have no bottom outliers. Okay. Now we are going to graph these bad boys. And I will be able to explain the 1.5 a little bit more. I'm going to go by twos because I don't think there's enough room to go by ones. All right. So now I am going to put the students in, and I'm going to need some help remembering that, well, maybe not, because you know what? I have the paper right here. I did, it's right here, right here. Okay, so first I'm going to put that they are the students. And the minimum is at 3.75, so that's going to be about right here. And I'm going to put 3.75 by that dot. I should put it closer, but I'm really bad at this for some reason today, and maybe always, to be honest. 6.75 is going to be about right here. It's actually up a little bit higher, but close enough. The median is 9.25, so that's about right here. And the upper quartiles at 13.75, so that's about right here. And the maximum is at 1650, so it's about right there. So I can draw my box, and I can put my whiskers. See, that's the best I've done all day, so just deal with it.
Yeah.
As my niece would say to my mother, when we would go out to eat, Barbara always found something wrong with her food. This is a little blackened. I don't like the texture of these beans. And Bobby Lynn, who is now a freshman in college, would just say, oh, Grandma, just deal with it. And then the rest of us would kind of laugh. Because Bobby Lynn could say that and not get in trouble when you're 5 or 6 years old, but everybody else would get in trouble. Okay. All right, so let's now do the faculty, teachers, whatever. I have to put in faculty because, you know, James, I'm sure, was in the obstacle course with us. Okay, the minimum was 4.50, so about right there. 4.5. Q1 is where? 8.75, so it's up here, and I usually don't start low enough, but I think that might work. And you know what? Ms. Fogger would be horrified all day long. I have not labeled or titled these boxes. Oh! I'll have to do better right now. Median, 11. Right there. Q3, 15.75. I know I have an outlier up here at 30, which I put as an asterisk. And where does my whisker stop? Because some of us always do this wrong. You really have two choices, and the first choice is probably wrong. I do not stop the whisker at the 26.25. That is not a piece of data. What's the next piece of data below 30, according to this problem? Anybody? 24. How'd you get that? Oh, it's in the prompt. Oh, yeah. Okay. So 24, right there is where the whisker should end because that's actual data. So let me demonstrate what the box plot outlier thing is doing. I will use a piece of green fluorescent paper. Okay, this is what it's doing. The first thing is you come in here and you measure how big is that IQR. So I think I have it. Yep, this first fold, that's how big the IQR is. Right there, okay? That's how big my box is. I need that plus half of it. Well, if I do half of it, that takes me to right here. All right. So now I have the box, which is this, plus 50% more. That is my measuring stick. And so I'm going to turn it into more of a stick-like figure. Highly sophisticated mathematics going on here. All right. This is the stick that I now apply to the top of the box. Is there anybody outside the top of this box? Yeah, 30. So he's an outlier. Put it at the bottom of the box. Is there anybody below? Nope. And it just so happens in this problem, that box is the same width, so I can use this again. So take that, 50% more. Is there anybody over here? Nope. Is there anybody down here? Nope. So really, if you did a non-modified box plot, this whisker would go all the way out to 30 at the beginning, and we wouldn't even care about the 24. If you didn't do the outlier test first, and you did this instead, you did a folding technique, you would put this down and you would say, ooh, yeah, there's stuff out here that's not good. So somewhere that 30 is definitely an outlier. And now I have to go look at the data set and see where I should erase to. And I think it was Tyler that told us we should erase to the 24. Because that's the piece of data they told us about at the top. All right? Okay, now it says, write a few sentences comparing the variability of the two distributions. What does the word variability pertain to? Standard deviation, do we have that? Nope. What else? What's another measure of variability? Nope, that's a measure of center. Nope, you guys are making this too hard. Range or spread. Those are all measures of spread. Okay? So I like to regurgitate the prompt back to them. The student distribution has more or less variability than the faculty distribution. of time, of times. I put context in there. And now I'm not done because I have not given them statistics. The range of student times is, what is it? 12.75, I think. 12.7 minutes, which is smaller than the range of faculty, F-A-C-U-L-T-Y, F-A-C-U-L-T-Y, times, which is from 30 all the way down to 4.5, so that's going to be 25.5 minutes. When you read an answer on your AP test, you should know what it's pertaining to. This is something about time and minutes. Yep. So I better put my labels in so Mrs. Blogger doesn't come yell at us. Down below here, these are minutes. And the title for this should be Field Day Obstacle Course. Did I spell obstacle right? Because it's an obstacle for me right now.
I think you spelled.
Yeah, it looks like an I, but that's really supposed to be an L. Let me fix the L. Words just, I don't know. Words look weird to me at times. Like the word room, that looked really strange a couple days ago. I don't know. That's why I teach math and not English. I have 2 letters of recommendation I need to write by Wednesday, and it's killing me. It's okay. I can do it. I did one last week. I can get 2 more done. I'm going to get one of them done tonight, so it isn't like death to Pamela. It's like swinging. Write the letter of recommendation. Write the letter. I don't know. You guys, does anybody feel like that when you have a report to write? I'm like, words?
Still way better.
Yeah, but if I get it done, it's over with. One's from somebody who graduated 3 years ago.
I don't know. You could just like not think about it.
Yeah, I could just say no, but then that's usually not me. All right, any questions? Now, you actually don't have to use outliers in this next thing you're going to do, but you are going to be doing it with Boxplots, and this is one of my favorite all-time AP questions from years gone by, and it's only been 3 years. But when they came out with this question, I was like, that is awesome. So you're going to have 7 minutes. Now, don't be a Mr. Kale. Please listen to my directions. I am giving you this paper. You can either take notes on the side of this paper or take notes on a separate sheet of paper, but I would not write your final answers until you and your team can get together and write your final answers together. So this is a thinking 7 minutes, and jot down some ideas, and like I said, either on a separate piece of paper or on this piece of paper, but you need to pouch your phones and put everything else away except for a pencil. You don't even really need your calculator, but if you're having trouble with subtraction today, you might want it. So you need either a blank piece of paper and a pencil, or just,
Use a colored pencil.
yeah, but don't fill all this out yet. That's what Kale did. Then he had to start from scratch. Okay, Lily, so we're doing the chemicals, pottery, and Boxplot now. All right? And I will set the timer once everybody gets theirs. There is a back side. Make sure you read closely and just answer the question that's asked, not everything you think you might want to tell them about Boxplots. And then I am going to semi-randomly form groups. Oh, and this is going to count for 20 points. You and your team will all score the same. And I'll explain how that is done later. All right, go ahead and get E started. All right, stop that, Mrs. Garrett. Okay. All right. Lily is going to be working with Nick, Nelson, Michael, and Rachel Bender. And I'm going to have you guys come outside. I don't know if you want to take desks outside. I'm going to take Lily outside on the Chromebook. You can sit on the floor, just like against the lockers and be 6 foot. Or you can slide desks out. So you guys come on out. Lily, when you are done with your final copy, just email it to me, okay? All right. So you guys come on out here to the working with her. Okay, I turn my sound off in there. Okay? So you guys can put her there and might be apart from on top of each other. All right, let me turn my volume down here.